Well, hello everyone. Yes, it is a late night, but let's have some fun with Audrey. I know that sounds weird. So if anything, right now what we're going to do is tonight we're going to work on composite functions. So composite functions, we're basically looking at no, hold on. There you go. Just trying to get my cat to basically chill, but you know, that went wrong. Okay, so with composite functions, we basically have two types. So if we take a look, we have what's called the FOG, F of G, and GOF, G of F. So what's happening when you have your composite functions is that means you have a function within a function. So if you ever see and it's not a dot. Now, if it was a dot, that would just be multiplication. But if it's like a small circle and it looks like it spells the word FOG, that means the G function is actually going to be inserted into the F function. So you might see it like this, and it says F of G of X. Whereas GOF, this is saying that the F function is going to be inserted into the G function. So I like to think of it this way. You got to think from your inside out. So we have a little example here. So when we're looking at the example, we have f of x is equal to 2x plus 4, and we have the g of x, which is 3x minus 1. And the first one we want to get is our FOG, our f of g of x. So this, if I may write it out this way, means we got the f of g of x. So this is telling me that I'm going to take this g function, which is this g function, and I'll substitute it for the x, this whole entire expression, and I'm going to shoot it in for the x. So it's going to look something like this. So we have our f of x. So that means we have 2 parentheses. So inside of this parenthesis, I'm going to put my g function, which is 3x minus 1. Then I have my plus 4. All right. So the way that we're going to do it is all we did was substitute that 3x minus 1 in for the x in the f function. So the g function is going into the f function. So now from here, all we have to do is solve. So we're going to distribute this 2 to everything inside of its parenthesis. So 2 times 3x gives me 6x. 2 times negative 1 gives me a negative 2. And then I just bring down the plus 4. So as I simplify, I notice right here, I have like terms with my negative 2 and the plus 4. So I can go ahead and combine those two. So then I will have 6x, and this will give me a positive 2, so plus 2. And then I don't do anything else from that. That's it. Okay? So all this is doing is saying that I'm taking my g function and I'm plugging it in for the value of x in the f function. So that's why you always want to work from the inside out. Now, if I wanted to, I can go the other way. If I wanted to go GOF, if I just want to go golfing, right? So I'll have my g of f of x. Okay? So this is telling me that I'm taking my f function and it's going in place of the x in my g function. So that means this expression is going in for the x in my g expression. Okay? I see someone's like, I hate these damn equations, but it's okay. So the f of x is going into the g. So that means my outer is going to be 3, and I have a parenthesis, minus 1. And what's going in is my 2x plus 4. So the f function is going into the x value in the g function. Once you do that substitution, now you can just go ahead and work your distribution. So 3 times 2x gives me 6x, plus 3 times 4 gives me 12. Bring down the minus 1. So like we saw right here, we have like terms. So I have my 6x, and this will be a plus 11. So this is going to represent the golf, but this first one represents the fog. Okay? All right, let's take a look. Let's see how you guys doing. Oh, thank you for the love. Thank you for the follows. What type of math is this? This is algebra. This is basically, I want to say Algebra 1 into Algebra 2. All right. Fractions. Okay. So we're plugging it in. All right. A lot of people joining in and joining out. That's fine. That's great. All right. So now that we have that, let's talk about the next one. So the next one, what happens if we have a little bit of squarage going on here? And we have a term. So let me separate these guys. And then we have, let's say, the f of x. That's going to equal x minus 5. And the g of x, that's going to be 6 plus 2x. So let's first find the fog. Okay, so let's first find that fog. So that means the g of x is going into the f of x. So if I have my 6 plus 2x and it's going in for the x, that means we're looking at parenthesis minus 5. And inside that parenthesis, let's see if I can put my right pen on there. Inside the parentheses is going to be our 6 plus 2x. So this expression went in for the x in that equation. So now, let's kind of put things in perspective. We don't have anything to distribute other than a 1. So basically, you still have your 6x. So you still have your 6 plus 2x, actually, minus 5. When you combine your like terms, you'll notice you're going to have your 2x plus 1. Because 6 and minus 5, that gives me a positive 1. So this, since we can't combine the 2x and the 1, that will give us our fog. If we go the other way, we can go for a GOF. So the G of F. So this is telling me my f of x is going to go into my g. So that means we have our 6 plus 2, but instead of an x, we're going to put in our x minus 5. So once we do our substitution, we're going to go right into our distribution. So when we do that, we have our 6 plus 2 times x gives me 2x, and 2 times negative 5 gives me negative 10. So combine your like terms. Okay, so we're going to combine our like terms, so we still have our 2x, but we have 6 minus 10, that gives me a negative 4. And that's going to be a result because you can't combine 2x with your negative 4 because they're not like terms. All right, how are we feeling so far? Okay, feeling pretty okay? Now, I want to take it a step further. So what happens, still keeping with the same functions, okay? You could factor it, but then go where? Yep. If you factor it, you're going to still put it back in because they just want to know what the composite numbers are, okay? So you could just leave it. I know, it's so tempting to just keep factoring and stuff. But what happens if I take it a step further? Still using the same functions, but I want to do, let's say, the f of g, but I'm actually going to put a 3 in there. Whoa. So I'm actually putting a number in there. All right. Thank you so much for the follow, guys, and the likes. All right. So what's different is that we have a 3 in for our value. We normally would have an x. But since we're still doing the exact same thing, we're still going to have the g function being entered into the f function. But we need to do something to the g function first. They're saying, if I have my f function, so instead of an x, we're going to be doing some substitution. But inside the g function, we're saying there's going to be a 6 plus 2, but not just 2x. It's going to be 2 times 3. Because as you can see, there's a 3 that's in the same spot where x would be. Okay? So I have to take care from the inside out. Okay? So when I see an x in the g function, here's the g function. Where is there an x? There's an x right there. And instead of me writing an x, I'm going to write a 3. So that's where this came from. So now, when we take it a step further, let's do, just like order of operations, do what's inside the parenthesis first. So in this case, we have we have 2 times 3 right here, which gives us 6. So now we have 6 plus 6. And again, it's still in the parentheses. The 6 plus 6, that gives me 12. Then I bring down the minus 5. Okay? 12 minus 5 will give me what? Twelve minus 5 will give me what? What do we got? Thank you for the love and for joining in, coming in. Hey, Jordan. Hey, Dot. Okay, good, good. All right, we got our 7s and 7s and 7s. Okay, so we took care of the G function, which is inside our parenthesis. We took that answer and put it into the F function. That's where the minus 5 came from, because the F function is x minus 5. So our end result is going to be 7. Okay. Let's try another one. So if I say, let's stick with this pen. So I'm just going to do this so we can get the separation going. All right, so if I said the f of x is equal to x squared plus 3, and the g of x is equal to 2x plus 1. Okay, so this time we have a square. Okay. Ew, can you say please, Giselle? Make a YouTube video, I need to learn this. Do you have YouTube? I love how you demand the video. And you don't even know if I had a YouTube first. You're hilarious. I do have a YouTube video. Yes, I do have a YouTube channel. Just cracking me up right now. But I also have tutoring. I have a tutoring service as well. Okay. I appreciate you saying that. Thank you. Because I know it's like, I need this. And it's like, I know the sounds of desperation. I can hear it. All right. So we are going to, I'm just going to simplify it. We're going to have our fog. So it's the f of g of x. And remember, the f of g of x, it means simply this. You're going to have your g function inside the f function. So that means this 2x plus 1 is going to go in for the x value in the f function. So if I may, I'm going to put a parenthesis, and it's going to be squared, and it's going to be plus 3. And what goes inside will be a 2x plus 1. Yeah. So the g always go from the inside, substituting into the outside, and you're substituting in for the x value. So now we're going to advance it up. So we have 2x plus 1 squared plus 3. So it's not as simple as, oh, let me just square the 2x and let me just square the 1. No. Okay? What you are actually doing is you're writing this base twice. You're going to have to do what's called FOIL. So it's going to be 2x plus 1 and 2x plus 1. So you're writing this base, which right now your base is an expression, writing that expression out twice and bringing down the plus 3. All right. So now, with that bit of information, we are, which is going to be, everything's red. We're going to do FOIL. So this first 2x, I'm going to distribute to everything in that second parenthesis. So 2x times 2x, that gives me 4x squared. Because 2 times 2 gives me 4, and x times x gives me x squared. When you multiply, you add the exponents. Plus 2x times 1, that simply gives me 2x. And now you're going to distribute this 1 to everything in that second parenthesis. Anything times 1 is going to be itself. And then I bring down the plus 3. I could also do the square method, but it's going to be hard for you to do the square method because you need, actually you can't, because it's not an equation. You're just plugging in expressions. So it's going to be hard for you to do the square method. Almost forgot. It's been a long day of tutoring. Okay, so in order for you to do the square method, that means it has to equal 0. And that's not the situation here. Okay? So now, we got like terms. So you have your 4x squared plus 4x. Now, you also have like terms right here with the 1 and the 3. You have a set of like terms here with the 2x's. That's where the 4x came from. Then 1 plus 3. That gives us our 4. Okay. In parentheses. What still? No, once you distribute, after you do your distribution, the parentheses are gone. Because think about it. The reason why you use parentheses is to represent multiplication. So once you did that distribution, which is multiplication, they go away. Okay, so that's when you know. Once you finish multiplying, and right now we're just combining like terms, boom, you're done with that. Okay? All right. So, since we already did the substitution of the g of x into the x and the f function, we did our distributive property, which gave us our 4x squared plus 2x plus 2x plus 1, and we brought down the plus 3, combined like terms, and we get 4x squared plus 4x plus 4. Now, a lot of people are like, well, can we just factor? Can we factor out the 4? And I'm like, you can. It's not going to get you anywhere, but yeah, you can. All right. Hey, Steph. Does that only apply to 4x? The reason why there's an exponent with the 4x, because when I multiply the 2x and the 2x, the 2 times 2 gives me 4, but when I had 2 x's to multiply, that's where this 2 came from. But if I try to multiply the 2x with the 1, there's only one x, so I don't have to worry about exponents. Okay, so the only time I had to worry about is when I multiply x times x. When you multiply, you add the exponents. Okay, not a problem. All right. So, that takes care of your fog, right? 24, Sheldon? 24 what? You just wanted to yell out 24? Are we playing bingo? B64. Snake eyes. No. All right. So let's go the other direction. So we did fog. Let's go ahead and do golf. All right. So this time, my f function, which is that x squared plus 3, that's going into the g function. Okay? I know. Trust me, a lot of students used to be like, G unit? I'm like, okay, here we go. All right? So the g unit is going to be what's on the outside. So we have 2 parentheses plus 1. What's going inside is my f, which is my x squared plus 3. Okay. So now, the only thing that we have to distribute is this 2 to everything inside of the parenthesis. So 2 times x squared gives me 2x squared. Plus 2 times 3 gives me 6. And then we bring down the plus 1. And if you haven't noticed, we got like terms right here. So all we need to do is combine our like terms. So you have 2x squared plus 7. And that's your answer. Oh, I forgot to box my answer over here. Okay. Hey, California. No worries. All right. So that's what we're doing with the composite figures. Okay. Solve for x. You're about to solve for x, right? But see, that's the thing. Since there isn't a variable or there isn't a representation for the x's, all we're doing is playing around to get our expressions together. That's all you're doing, is just merging expressions. All right. Now, that was composite functions. So now I just want to address one more thing. Like tonight might actually be like a really quick night. So you can't combine them? Yes, that's exactly what you do, Steffi. Or Steph. That's exactly what you do. All right. So now I'm going to add on. And I want us to find the inverse. And you're probably like, what? We want to find the inverse. So, for an example, if I had the f function was equal to x squared, and the g function represents the square root of x. In order for me to find the inverse, I have to substitute, or to verify inverses, but we're going to try to find the inverse. So if I were to find the inverse of this f function, okay, and the symbol, if it was an f function, is going to be the f of -1 of x. So if it's an f function or just whatever the name of the function is with a -1 on top and of the x. So what we're doing, and it's a simple concept, and I'm just going to write that over here. So first we're going to switch the x and y. Oops, ran out of room. Okay, we're going to switch the x and y, and then you're going to solve for y. And then you're going to sub that y, sub the f of negative 1 of x for y. Okay? So these are what we're going to do. If I want to call them steps, I'll call them steps. And then I'll move my hand in a second. Okay? So we're going to switch the x and y's. Then we're going to solve the equation for y. And then we're going to substitute whatever the name of the function is with the negative 1 as an exponent. That means inverse of x for the y. Okay. Can I do 2 plus 2? Junior, I mean, that's a toughie. That's a toughie. Going college algebra, I'm trying so hard. Oh, Jessica. Tomorrow is what? Tomorrow is Monday. And I normally come on at 1. I got 1 in the afternoon, but I think I'm gonna come late. Insert jokes there. I'm so immature. And it's, God's just shaking his head like, ugh, can't take her anywhere. I am probably going to start like around either 9:30 or possibly 10 tomorrow. Yeah, it's either 9:30 or 10. Okay, but I know I'll come on at 1 o'clock. Okay. All right. Okay. All right. So now we are going to solve each of these functions. And I'm going to use different colored pens or pencils so you can follow along. Now, f of x is the same as saying y equals. Okay, f of x, it means function of x. The function of x is always your y values. So, next step, we need to switch our x and our y's. So that means we have x equals y squared. Okay, notice how I switched it. My y is over here, my x is over there. All right. I know, my times are always so crazy. So, especially this time of year, like everybody's looking for a tutor right now because it's before or after spring break. It's third quarter. A lot of people either failed the semester. Their parents are like, you know what? You need a tutor. And then the insanity begins. And the insanity is probably going to grow even more so. So get me when you can. All right. So now we need to solve this for y. So that means I need to get this y by itself. What's the opposite of a square? And don't say a circle. They're like, oh, damn, I was about to say a circle. It's not a circle. What's the opposite of a square? That's an exponent. Here we go. There she is. Good. So we have a square root. These are inverses of each other. So since they're inverses of each other, the square root and the square, they cancel out. Which leads me with, I'm going to bring down my equal sign, and I bring down my y. So now, what's left is the square root of x. So if you want to, you could switch it around, but we need to finish it off with f with the negative 1 of x is equal to the square root of x. All right. This is my answer. Okay, so we switched the x and the y's. We solve for y. Then we substitute the y with our f raised to negative 1 of x. So this means the inverse of x. All right. Can it also be plus minus square root of x? Not in this case. Not in this case, because right now we're just trying to find the inverse, not the intercepts. That's why. But you are thinking. Good job. Okay. So what does it even mean that you can find your inverse functions? So if I do the opposites, okay, now we got g of x. Now, if you could take a guess, what do you think the inverse is going to be of the g of x? Factoring without a term? You can't factor without a term. You have to have terms in order to factor. Good job, though. Okay. All right. Possible Kim. Oh, it's almost like Kim possible, but in the reverse. Yes, we got x squared. You think it's x squared? An a term. You always have to have an a term. 77. Without an a term, you always have an a term. If there's nothing there, it's assumed to be a 1. Is that what you're talking about? 77? 77? Double 7? 7 squared? Okay. All right. So, yes, thank you. Okay, let's see what I can do. So, g of x, regardless if it's a g of x or f of x, it still equates to y. All right, so we set it for our y. Now we got to switch it. So that means we have x equals the square root of y. Okay, g of x turned into a y. Got our square root of x. Switch the x and y's. That's where the x equals the square root of y. But now we need to solve for y. So if we need to solve for y, we got to do the opposite or the inverse of a square root, which is a square. And whatever you do on one side, you must do on the other side. So now your square and your square root are going to cancel out. And just like, who said it? I want to give you credit. Wait, who said x squared? Where'd it go? Kim Possible in reverse. Possible Kim. All right. Possible Kim. Me. All right. Cool. What math can I teach up to? I feel comfortable up to pre-calculus. Right? So that means this gives us our x squared. And instead of just keeping with the y, let's put our inverse in there. Equals x squared. Okay. Good. I know. I love how everyone is into the AP pre-calculus. So many students are having trouble with that. So many. I'm at the point where I don't like it. Because it's just like so much extra stuff. So crazy. Okay, cool. Well, thank you. All right. Yup, until trig. I know. It's like there's certain parts of trig that was like kind of cool, and then you're like, why? Just why? Yeah, but I'm starting to get used to it because I guess when you teach it, you're just like, oh, okay, this is how we do it. All right, one more thing, because this is just, solving. So verifying inverses, and then I'll see if I can get into the factoring. Okay. So, in order for us to verify, to see if they are inverses, we're going to be kind of using that fog goth that we did, I'm about to flip, that we did earlier. Okay, so when we do the fog, that means the G function goes into the F function. When we do goth, we got the F function going into the G function. So similar things are happening. So if I give us, we have the f of x is equal to the cube root. What? Cube root? Yeah, we're going to do it. Cube root with plus 1. And then we're saying the g of x. Probably going to have to unzoom just a little bit so we can see everything. Okay, and we're saying the g of x is our x cubed minus 1. Now, people that are doing the advanced math are probably like, oh yeah, they should be inverses of each other. Because just like when we said earlier, square roots and squares are inverses of each other. So shouldn't cube roots and cubes be inverses of each other? We can say that, okay? But we want to make sure, all right? Really require just intuition. Okay, and see, no problem. But this is what I do. Okay, cool. All right, got that. So, if we're to do fog, we're going to take our G function and put it into our F function. So that means we have the cube root of what we're going to put in for x plus 1. And what's going in is your G function, which is our x cubed minus 1. So with this information, there's a lot of stuff that's going underneath this cube root. Okay, don't be intimidated. Although I put parentheses around, I always do that anytime I substitute so you can see what I substitute in for the x. So, but we got like terms right here. So -1 plus 1. -1 and plus 1, they cancel each other out. Now what's left is this x cubed. So -1 plus 1 cancels each other out. So now what's left is the cube root of x cubed. Now, as I mentioned earlier, the inverse, if I may slide down, the inverse of a square is a square root. So the inverse of a cube is a cube root. What do you think is my final answer? Oops. Okay, end up with x. Good. because cube and the cube root cancel each other out. What's left is going to be your x. Okay, good. So now we got this other function. And what we want to do with that one is we're going to do golf. Now golf is when you take your f of x and you substitute that function into the g. So this time the outer is going to be parenthesis cube minus 1. And what goes inside is our f function, which is the cube root of x plus 1. Okay. Yeah, of course. Nice and slow, straight chill. Keep it chill. So now, the inverse of a cube root is a cube. So right off the bat, they cancel each other out. And what's left is what was underneath the radical, which is our x plus 1. And then we bring down the minus 1. What do you notice next? Hey, C-Mac. How are you? Good, it cancels out. We do have those like terms that we can combine. It's x, baby. Yeah. Yeah, because 1 minus 1 gives us 0. So they cancel out, leaving me with x. So when I get answers, when I plug them in and I get x as my answers, this is telling me, this is good, okay? This is good because it's telling me that these two expressions are inverses of each other. So if I were to graph them, they're going to be reflexive. Remember we talked about the axis of symmetry? It's going to be somewhat similar reflexive. So it's like one side is going to be a mirror image of the other. Okay, so it's good that our answers will equal x. That's how you know. So if you ever see a question that asks you, are these two inverses of each other? You plug them in. Plug them in to see if it works. All right, we'll do one more and then we all done. So are these two inverses of each other? While we're doing that, I'm going to see if I can pull a couple of factoring ones. Okay. So are these two inverses of each other? Oh, well, thank you. I never thought I would ever have a bee follow me. Thank you, that bee. I would say the actual word, but you know, might get a little sensitive. So see if you can work it out. I want to see if you can work it out. I'm going to give you a couple minutes and then I'm going to come back and show our answers, okay? Okay, Bunny. Yep. So yoga. I'm saying there are inverses. Okay, WHS said they are inverses. Okay, so I got 2 confirmations. Okay. Ready for justification? Or do you need a couple more minutes? right. So if I'm going with fog, that means I'm going to plug in this G function into the F function. So I got my 2, my nice parenthesis, minus 4. Inside I have my x plus 4 is over 2. Now, I know some of you guys probably saw the fraction. You were like, nope, I'm not doing that. But then take a look. The whole number and the denominator are the same number. So it's almost like me saying 2 divided by 2, which gives me a 1. Oops. There we go. All right. So anything times 1 is itself. So what comes down is going to be our x plus 4. Then I just bring down this negative 4. So when the whole number and the denominator are the same, they can cancel out. It's actually dividing and giving you 1. But we all know once you get down here, you don't have to multiply this x plus 4 with 1 because you're going to get the same stuff, right? But then take a look here. We got like terms. So we have positive 4 minus 4. That cancels out because that gives me 0. So now we have equals x. And that's what we wanted to see. That's exactly what we wanted to see. So it's giving me hope. Now, here's the thing. Ready? Shaking the finger at you. Now, here's the thing. Just because it worked for the first doesn't necessarily mean it's automatically going to work for the second. You have to do it both times. I know you're like, they're doing too much. It's too extra. I just want to blah, blah, blah. Yes, but you have to do both because I have seen some that it works for one, but it doesn't necessarily work for the other. So now we're going to go with Goff. So that means I'm taking this expression in the F function and I'm going to substitute it for X in the G function. All right. So we have, I know every time I say G function, I just automatically think of G unit. I know. That's the society that we live in. So that means I have my 2x minus 4 is going in for the x. Then I have my plus 4, and it's over 2. All right. So now up here in the numerator, negative 4, positive 4, they cancel out. Okay, that gives me 0. So now what's left is my 2x over 2. And 2x divided by 2 will be 1x, or just x. Okay? So, both of my answers are going to be x. So that means, yes, they are inverses of each other. Well, thank you. All right, so yes, heavy hitter, yes, there are inverses of each other. Quadratic formulas too? Really? Okay. All right, I think everybody's doing quadratic tonight. What's going on? All right, so I had a request. And I'm going to use my notebook for it. So let's see. I definitely have some room, but there are some things I want to show you guys later. All right. All right. Let's see what kind of trouble we can get into. All right. So we have factoring. I could say it that way. Factoring quadratics. Okay. So, have a couple of problems. So, one of them was when my A was, when they said there was no A. There's always an A. Okay, minus 6x minus 27. All right. Now, when you don't see a number in front of the x squared, oh wait, hold on. Just in time for me to do the slide. Okay. Guess I just want to make sure I'm still here. I'm still here. Okay. When your leading coefficient, so basically the number that's in front of your x squared, if you don't see anything there, it's assumed that it's a 1, which is great because then I can go right to my parentheses. And what I'm going to do is I'm going to do what's called split my x's. So one x is going to go in one parenthesis, another x is going to go in the other. So now, this is the hardest part. So we need to think of what two numbers, some people like to do a cross, what two numbers multiplied will give me a negative 27, okay, and add together, the same two numbers add together to give me 6. So two numbers multiplied together give me a negative 27 and add together to give me a negative 6. Just because of this factor problem, this is why I put this in my math notebook. We go with the factor form. Okay? So inside my notebook, I want to get to 27. All right, so here's 27. The only factors of 27 that I have is 1 and 27 and 3 and 9. Now, 3 and 9 could probably help me out here because I know one of these two have to be negative, and if I subtract these two, I know I can get a 6 out of there. So 3 and 9 are going to be, my factors for this. So I have a 3 here and a 9 here. But since we're looking for a negative 27, one of these have to be negative. And if I add those, the same signs, same numbers that we got for the negative 27 has to work for the negative 6. So since this has to be negative, my largest number is going to have to be negative. Because negative 9 plus 3 gives me a negative 6. Negative 9 times 3 gives me a negative 27. So since this is a positive 3, we go plus 3. And since this is a negative 9, we say minus 9. And that is factored. Okay, good, Peggy. Hey, Peggy. All right, let's do a couple more. Let's go here. So we have x squared minus 11x minus 42. Just did a double negative one. All right, we'll solve this one, but I'll do a different one. Okay, so now my leading coefficient is 1. So right away, all I'm doing is splitting my x's. So now I need two numbers multiplied together to give me a negative 42 and add together to give me a negative 11. All right. So you can play around with your calculator, or we can come here, whoops, take a look at our 42s. So we got 1 and 42, 2 and 21, 3 and 14, and 6 and 7. So we're looking for two numbers that, if I either add them together or subtract them, will give me 11. So if I go, I know if I subtract these two, then neither one of those is going to give me 11. This one will give me like a 1. This one can give me 11, because 14 minus 3, that does give me 11. So it could be 3 and 4. 14, sorry. But which one is going to be negative? The 3 or the 4? Been here. I know. Bri, where have you been? All right, King. Hey, so. All right. 777. Yes. Oh, Kick Punch Artist. You had it first. Good. Nice. So it's not going to be the 3, because if I add them together, 14, like if I have $14 and I spent 3, that means I still have $11 in my pocket. This is a negative $11. Like I owe somebody $11. So that means if I have $3 and I want to buy something that was 14, that means I am short $11. So the 14 is going to be the one that's negative. So then you come over here. Since it's a positive 3, you write plus 3. And since it's a negative 14, you write minus 14. Okay, all right, good. Aw, awesome. Well, congrats. Okay. Well, it's good. You have a new living situation, so that's exciting. And your new job, look at you, starting fresh and new. Fresh and so clean. Clean. Nice. Congratulations. I'm proud of you. Because it's hard. It's not easy starting anew. Yeah, we're not doing completing the square tonight. I already did that. And you can go to my YouTube channel, because the video is there. All right. So now we'll have okay. Luckily, I do have some of these. So if I have 3x squared plus 11x minus 4. So now, right now, our leading coefficient is not 1. So I can't do that shortcut. I can't do that split. But what I will do is I'm going to list what my A value is, what my B value is, and what my C value is. So what I mean by A, B, and C is that this is in standard form. Your A value is always what's in front of your x squared. Your B value is always the coefficient of the x, and your C value is your constant, and all that is with the sign. So in my case, my A is going to be 3, my B is going to be 11, and my C is negative 4. So, remember this cross that we did over here? We're going to do it a little bit sooner. So we need to know. I'm going to multiply my A and my C, put the result in this box, and just rewrite my B and put that result in this box. My A and my C is 3 times negative 4. So 3 times negative 4, that's a negative 12. And the B is 11. Okay, so let me pause to see how we're doing. And a driver's license? Look at you. You are really... You are really turning your life all kinds of around. Woo! You go. Go, Bri. I appreciate you. I'm so proud. That's awesome. Okay. Joshua! I have so many Joshuas. It's so funny. Okay. Hey, Caitlin. Hey, Danielle. How are you? All right. So you're thinking -1 and 12. You're thinking 12 and -1. All right. So we have our 12. We have our -1. Because 12 times -1 gives me -12. And 12 plus -1 gives me a positive 11. This is where it differs. Okay? I'm doing what's called the AC method. So instead of putting them inside of parentheses, we can set up what is called, some people like to replace the center and do grouping. Some people like myself, I would put up 2 different ratios. The numerator for my ratio is always the A and the variable. And that's going to be for both of them. So my A value is 3. And the variable that we're using is X. The reason why I write it out twice is because of my highest degree. The highest exponent was to the second. What goes underneath is basically the 2 numbers that we found to satisfy the situation. One's going to go under one, and the other is going to go on the other. So that means I have 12 here, and I have a -1 here. All right. Yes, so you always multiply the A and the C. That's how you get the -12. And then you just rewrite the B. Okay. So, we got 2 fractions here. This first fraction can be simplified. What number does 3 and 12 have in common? It will give me a result of 4. It will give me a result in 4. But what they do have in common, yes, they have a 3 in common, because I can't divide this 3 by 4 because it's not going to give me an even number. But if I divide it by 3 as well as the denominator, I will get 1 over 4, or 1x over 4. This second ratio, the only thing they have in common is 1. So this is basically our answer. Each ratio is a parenthesis. This first one is 1x, or just x, plus 4. The second one is 3x minus 1. So that's called the AC method. Yes. Okay. Okay. If I use the same numbers, this until I did this part, because remember, there's always more than one way. you could replace that 12 and the -1, you can replace it with the 11. So I'm giving you a choice on to solve it. If I replace it with the 11, it's going to look like this. 3x squared plus 12x minus 1x minus 4. So I replaced the 11x with the factors that we got from the -12 and the 11. Some of you guys, your teacher probably teaches through grouping. So if I look at the greatest common factor of this first parenthesis, it will give me 3x. And if I divided the 3x squared, that will give me x. And what happens? I have 2 x's up here. I took one of the x's away. That means there's 1 x left. Bring down the plus sign. Okay. 12x divided by 3x. 12 divided by 3, that'll give me 4. I have 1x. I took 1x out. There is no x's left. Okay. All right. So now we have a negative. So I'm pulling that negative out. And the only thing that 1x and -4x have in common is a 1. So a negative divided by a negative will give me a positive. That'll be x. And -4 divided by -1, that will give me a positive 4. Okay? Yep, I do have a YouTube channel. You can just type my name, Audrey Codner. And I generally put my, replays. I have a playlist for my replays of my lives on your TikTok. But I'm not going to put tonight's up until tomorrow. You're welcome. Okay. So from here, I notice that inside the parentheses are exactly the same. So it's like that's the GCF of that line. And then what remains, my 3x minus 1, that's my other parenthesis. Okay? What do you notice? Okay? You get the same answer, no matter what you want. GCF means greatest common factor. So what do they all have in common? No. Because I'm not multiplying right here, that's why I can't do x plus 4 squared. Okay, if this 3x and that minus 1 wasn't there, yes. Yes, but since it's there, I can't do that. Okay. All right. How do you know which goes with multiplying? What do you mean? How do I know which goes with multiplying and which goes with add and subtract? Do you mean the factoring piece? K. Smith? Yes, but the solution part too. Oh, okay. So it's like once you figure out, let's say with this part. Oops. So let's say once you figured out your 4 terms, you basically get them together, group them together. So now you find the GCF, the greatest common factor that 3 and 12 have in common, which is going to be 3. Then you have your x squared and your x. So they both have at least one x in common. So if you divide this original parenthesis by 3x, you're going to get a positive x, and you're going to get a positive 4. So since this leading coefficient is negative, you bring down the negative. And then 1 and 4, they all have 1 in common. So that means if I divide everything by a -1, a negative divided by a negative gives me positive, a negative divided by a negative gives me positive. So now, inside your parentheses are exactly the same. So that's the greatest common factor, what they both have the same. That's where that x plus 4 comes from. And everything outside the 3x minus 1 is going to go inside its own parenthesis. Yes. It is. It's a lot of rules. It's a lot of rules. Yep. Especially for subtracting, adding, subtracting, multiplying. Yep. There is so many rules. Okay. Let's see. It is. But that's what it takes, practice. That's the only way that you can kind of remember, by actually practicing, looking at some of the practice problems, doing some of the practice problems, really trying to master it. Because if you don't practice, it's not going to just naturally come to you. We all know, like, when you don't do it, you lose it, right? All right, so, oops, there we go. Do another example like the first part of the last example. Okay, yes. All right. As you could probably tell, I'm fading fast. I've been tutoring since 10. I am exhausted. All right, so this will be my last one. Yeah, because once I get loopy, it just... All right, so 10x squared plus 33x minus 7. So the first thing you should do is list what represents your A, what represents your B, what represents your C. All right. Oh, thanks. Yes. Good. Okay. So my A is going to be what's in front of the x squared. That's my 10. My B is going to be the coefficient in front of the x. That's 33. And my C is a -7. That's the constant. Okay. So in order for us to figure out our next step, we need to write our cross. We're going to multiply the A and the C, and we're just going to rewrite our B. Okay. So multiply the A and the C, you got -70. Rewrite the B, which is 33. Now I'm going to be truthful. This is usually the hardest part. This is the hardest part. Oh, good. Nice to meet you. Oh, hello, Carissa. How are you? Okay. Oh, not a problem. Okay. How is it negative 70? Because we have a negative 7 times a positive 10. Gives us a negative 70. Okay. Not good with negatives? Well, we're going to have to learn that. Because trust me, there's negatives everywhere we turn. All right, so we need to think of the factors of negative 70, or at least 70. So if I come, you can use your calculator, or if you have your handy dandy math notebook, you can go to 70, and you know one of these factors has to equal a negative, or has to be a negative, because we need for it to equal 33. So here I go with 70. So we have 1 and 70, we have 2 and 35, 5 and 14, and 7 and 10. Okay, so a lot of people are telling me, a couple people, yes, use a factor sheet. Yep. Table, not a cross. Some people do tables, I do crosses. Yep, that's perfectly fine. All right. This is pretty cool. Thank you, Dark Knight. Yeah, I created this because I got sick and tired of a lot of my students like, I don't know. So I'm like, use your sheet. And they're like, oh, this is amazing. Okay, so I'm seeing 2 and 35, but making the 35 negative. When you multiply them, all of them will equal negative 70. That's the purpose. But we need to look at these to see which ones, if I add them together and I make one of them negative, which one will give me 33 and negative 33. So it's going to be my 2 and 35. So we have our positive 2 and 35. Oh, actually, it should be the other way around. It should be negative 2 and positive 35, because my 33 is positive. So it's going to be a negative 2 and positive 35. So after we get that, since my leading coefficient is not 1, I can't just simply split my x's. But what I can do is either replace the 33 with the negative 2 and the 35, or I can set them up, as I had up here, as ratios. Which way would you guys prefer? Replace the middle term with these two factors, or do the fractions? Okay, so we got one with the ratios. Okay, let me come in a little bit. Okay, so now, got a couple ones. The first one you said. Okay, so if I do it with fractions, with ratios, you always put whatever your a is and the variable in the numerators. So my a's were tens, and the variable that we're using is x. So I'm writing out my 10x twice. The numbers that we found here, they're going to be the denominators for my ratios. So we have a negative 2 and a positive 35. So the 35 is not going to be negative because we needed a positive 33. I thought it was negative, but it's really positive. So, looking at our ratios, looking at this first one, this can be reduced. 10 and 2, they're both even. So that means they're both divisible by 2. So if I do 10 divided by 2, that'll give me a 5. If I do negative 2 divided by 2, that'll give me a negative 1. 10x over 35. 10 and 35. One ends in 0, the other ends in 5, so that's telling me it's divisible by 5. 10 divided by 5, that's 2. And 35 divided by 5, that's 7. So basically, my two ratios is 5x minus 1 and 2x over 7. Each of these ratios is a parenthesis. The first parenthesis deals with the first ratio. So we have 5x minus 1. For the second parenthesis, we have 2x, and since it's a positive 7, plus 7. These are your factors for 10x squared plus 33x minus 7. Not a problem. I kind of like it too. But I know some teachers said, our kids don't like fractions. So, and I'm like, well, they're going to have to get through that because that's all they're going to see. Especially when you get into advanced math. That's all you're going to see is fractions and decimals. Okay. Yep. Just have to take your time with it. Okay, I know. So many steps. Yep. I didn't like fractions either. I had to wrap my way around it. Yep. Okay. All right. Okay. All right. I'm about to pass out. I'm not even going to sugarcoat it. I literally almost fell asleep just that 2 seconds. I just took a sigh and I'm like, oh, man. Okay. Yes, please do. Please do. So tomorrow is Monday, because it seems like my schedule is getting all kinds of crazy because April, just before Easter, always gets crazy because that's when everybody's like, I need a tutor, and like they're expecting all this great miracles. So that's one. So, but I will probably be on later in the evenings like I am tonight, because of, got kids. But tomorrow I'm going to try to come on at 1. It might be at 1:15 because I forgot I got a kid at 12 now. But I would try. I would try to get on as best I can, like around 1:15. And then, but that has to be for an hour. That has to be, like I have to be gone at 2:15. And then I will come later, possibly like around 9, maybe 9:30 on Monday. But if I'm not on by 10 o'clock, I'm not coming on. But I'm going to try to. I'm going to try to at least come live at least once a day. And then, the rest of the week is probably going to be later. Okay? Because I got new kids or new adults for during the day. All right? Do I get any time for myself? No. Yeah, Saturday was my year, I guess we could say year anniversary of my divorce. That's funny. I don't know why I even thought about that, but it just did. How can we support you? Oh, well, thank you. Well, there is a couple of ways. So, as soon as I get my little cardy thingy out, thank you for reminding me. Either if you go on Google and you can do a Google review, guys, this helped me a lot because someone from the Baltimore Sun reached out to me and she said, because of your reviews, I had to reach out to you. And she interviewed me. It's in today's Baltimore Sun. And I'm actually front page news, dude. Front page news. It's talking about the 8th grade reading and math scores. Why is declining? Of course, of my hour-long conversation with her, she basically just took a little bit of quote, but I was the only math tutor. And they're trying to come up with this new program in Maryland. They're trying to get students to take 2 years of math, which is a mixture of Algebra 1, geometry, and statistics. And then they get to choose what their math alternative is for the 3rd and 4th year. Don't give students choice about math because they're going to be doing anything in their power to not take it. So, yeah, I can't wait to see this disaster kind of come around. But it helped me to get interviewed for the Baltimore Sun. I'm so excited about that. Can't wait to show my mom. I'm such a nerd. Like, where's my sticker? So if you can do a Google review, I'd greatly appreciate it. Just type in ACG Math Tutoring. And also, if you want to, this would be great, YouTube channel. Go Audrey Codner, ACG Math Tutoring. Subscribe. If you can subscribe, that'll be great. Take a look at a lot of the lives that I have on there. I still have to put up some more shorts. But all of my live recordings are on there. You can fast forward, you can slow it down, you can speed it up, do whatever you need to do. That'll be wonderful. But if you also love or like my notebook, okay, this is all the stuff that I usually do with the math notebook. Go ahead. This is what one of the covers look like. The other one is like a little psychedelic looking. There's 3 of the covers. They all have the same interior, 100 pages of the notes where you can have like your formulas on one side, and then you have your steps of how to do things. I like to have the dots to help with graphs, as you can see right here. And then the other side is the grids that also helps with graphs and gives you room for some extra practice problems, you know, anything of the sort. Then you have seen my factor sheet, okay? It goes from 1 to 200. A lot of people I've seen factor sheets before, and they will go to like maybe 100. Went all the way up to 200 since we usually deal with larger numbers. And also for those that just like, I just can't get these rules down, I got you. Here are the rules for adding, subtracting, multiplying, and dividing, which is underneath. So it kind of keep track of those things. We got our order of operations. We got our properties of exponents. Any of our rules with the equation of the line. We were kind of talking about the quadratic standard form. Okay, there's that quadratic formula. A lot of it is when you just know what your A, B, and your C is, you just plug it into the formula. That's why I feel like of all the quadratic ones, that's probably the easiest. Properties of quadrilaterals. If you're going into trig, you got your Pythagorean theorem, your SOHCAHTOA, your volume and surface areas, a little bit of geometry, as well as the unit circle. Oh yes, the unit circle. But sometimes you just need a moment just to debrief. I kind of give you a couple puzzles just to help you refocus. I call it brain breaks. You know, we all need a little bit of a brain break. You could probably do a little bit of coloring. And if you're into pixel art, you can go ahead and draw something or just go ahead and put it in a sketch. So if you're interested in purchasing a math notebook, trust me, you definitely need to get organized, okay? Most of the notebooks that are out there nowadays, let me see if I can unzoom so people can get the beginning. If anything, yeah. So if it's always designed, like there's a lot of notebooks, especially the spiral ones. Spiral notebooks to me just means temporary. You know, it's easy to rip out pages. It does what it needs to do, but it's not good for math. It's great that it lays down flat. That's the only benefit. But for math, you have to design your graphs. You have to design your ruling. And then sometimes it doesn't give you enough room to write in the margin, just like you would do with Cornell notes. So that's why you have all these little boxes to put stuff in. And then it kind of makes it easier for you to graph. All right. So if you're interested in there, Michael R. Solution manuals coming soon. Show news article again, please. Sure. So it was like the Baltimore Sun. I'm telling you, I think I might have to write a post about this because I didn't know about this whole thing. Whoops. Because our 8th grade scores are terrible. Years ago, especially after the pandemic, they decided to test the kids, which I still to this day was like, that was the stupidest thing to you to do. These kids were just trying to maintain calm and don't know what the injustice. A couple of their kids, their friends passed away, and they're just trying to figure out what to do next. And then as soon as they get back to school, oh, okay, well, we want you to take a state assessment in October. The hell? These kids didn't know, some people didn't even do anything, right? So then the test scores came back that 23 of our public and elementary, middle, and some high schools scored 0 in math proficiency. Like 0. Like they didn't get anything right at all. And they're like, oh my God, these teachers are doing horribly. No, stupid. You're giving them a test as soon as we came back from the pandemic. They haven't even got less green, used to acclimated back to being in the classroom. So that was going on. So then some of the kids did better. Okay, some of the schools, but we still have 6 or 7 schools that does poorly. I know, shaking your head. It's ridiculous, right? Oh, thank you. So then with a lot of the kids, a lot of the schools are our lowest schools. They were low before the pandemic. They were low for years ago. So of course, when this lady, she reached out to me. I didn't say, hey, volunteer. She emailed me because of my all the reviews that you guys were leaving and a lot of my former students, and I greatly appreciate that. And they just asked me, they're like, hey, did you know about this new concept? And I was like, it's probably going to be something that's going to speed things along. And she's like, how'd you know? And I'm like, they've been trying to speed up the concepts forever. And because they do that, that's how I can keep my business. Because they don't care how fast the kids learn it. They just care about how quickly the concept's going out and how it's going to make them look good. They don't understand that the kids need time, or people just need time for stuff to marinate, right? So you can definitely see the article. It's in the Baltimore Sun. You can look it up online. And it's under today's date. And I was like, yay! For once, I'm in the newspaper and it has nothing to do with sports. And it just really tickles me pink. Yay! So it's just moving in the right direction. Right. And I'm like, well, thank you. I really do. Thank you. And then I got news that well, I didn't get news. I officially got my seal, which I have to put on my stuff, that I'm Baltimore Businesswoman of the Year. So that's another thing. And all I can say is this is nothing but God. I don't know how people feel. Hopefully I'm not like insulting, but I've been on my journey not too long, and I just feel like he's saved me through so much. Especially these notebooks. This was his idea, and he just told me to put it together, and it took me one night to put this together. But then, of course, I was fooling around with it and perfecting it and all this stuff. So I just feel as though that I really do love and appreciate you guys coming out and supporting me. You know, either it's a math notebook, or if it's a Google review, or it's just coming on my YouTube channel and just really motivating me to keep moving forward. It's just like, thank you. Like, thank you. I mean, I work hard, and yes, as soon as I get off this live, I will say here, like, yeah, I'm going to go to bed. And then all of a sudden I get a text message from a parent. They're like, oh my gosh, my child, and I have a couple of kids that are on travel teams, and they will come home at these crazy hours after being at a tournament. And they're like, oh my God, he has a test tomorrow. Audrey, can you please? And I'm not going to say no. You know, regardless of how tired I may get, I will never say no if it's something that's going to be beneficial for another person. That's just me. I've always been that way. I don't know how to stop doing that. You know? And everybody's like, you know, I can rest. I can rest when I'm dead, you know? That's it. Right now, God has a purpose for me, and my purpose is to be here for you guys, and to help you guys, and to encourage you guys, and to push you guys, and, you know, hopefully to motivate you to go after what you want. Because I grow tired of seeing parents degrading their kids, or saying that, oh, I sucked at math, now you gotta suck at math. So it's like generational. Like, are you kidding me? So it's not generational. Yes. Well, thank you. I am. Thank you, Strawberry Squish. I appreciate it. Oh, thank you. I appreciate it so much. Of course, I'm always thinking about self-publishing, because as much as I appreciate Amazon being it, I would like to get a bigger cut. You know, because if I hear about Jeff Bezos going to do something stupid again, like, oh, I'm going to fly to space so I can play with a ping pong ball and then fly back down, I swear to Christmas, I'm going to lose my mind. Yeah, it's like, I feel like people are afraid of math, just like people are fearful of doing their taxes. And I'm not saying that I love doing my taxes. I'm like, oh, it brings me so much joy. But it's nothing to really be deathly afraid of. But I think because everyone worries about being audited, and it's just like, I don't want to be audited. I'm like, dude, what are you doing? Like, are you handling an underground drug ring? Like, what are you doing? Like, are you doing any of that? No? You're just like, are you having your own personal Squid Games going on in the backyard at midnight? You know, is that what's happening? No, you're not. You're basically going to work. I don't even know why we have to do all this stuff, but you're basically going to work. You got most of the stuff done. You put it in there, and then you get a little bit of change out of it, and then you spend more money because that's what they want you to do. But live life, man, because who knows? Who knows? No one knows when our time clock's going to be up. So I just feel like, look, while you're here, do the best that you can do. Don't let society, don't let your parents, your grandparents, trust me, they had an opportunity to live their life, right? They didn't take it. Too bad, so sad. That was their moment, right? But as you get older, I don't know how old everyone is, and I know things are tough and things look bleak and all this stuff. But no matter what, you know who you are. You know who you want to develop into. You know who you want to become, or have at least a good idea. Go after that. Don't wait. Oh, I'm going to wait until my money gets right. Your money's never going to get right because the government's going to make sure it never does. Okay? You want to travel? Put a little bit of change aside. If you want to if there's totally free checking accounts, get yourself a totally free checking account that's not connected to your current card, so you can't just easily take a little bit of something out of it, and be serious about saving up, and then do it big wherever you travel. Just do it freaking big. Be big bosses. You know what I'm saying? Just go. How about maybe if you have a little bit of cashola, if that's possible, like do some rich people stuff. Like fly if you're, I don't know, say I'm in Maryland. For some reason, I always use this as an example. I don't know why, but it sticks. That I want to go to Maine during the summer, not during the winter. Go to Maine to get a lobster roll. Like, just get on a flight to Maine, ask where's the best lobster roll, take me there, eat your lobster roll, maybe even tour the area, and then get back on the plane and come home. How about some rich boss stuff like that? Like, drop your kids off at school and then go catch a flight and go somewhere. So if you're not near a beach, go somewhere where you can get like a quick flight to the beach. Go to the beach, walk around, get in the water. You know, not just like, oh, this is cute. Like, get in the water, figure out, like, have a plan where you want to go and have lunch, and then fly back, pick up the kids. How amazing would that feel? Don't have to worry about luggage. Just go and travel. Why can't we do that? Right? Why can't we do that? Doesn't that sound that? I need a week vacation at least because I wouldn't want to go home. True. Yeah, one day, right? Hey, Andy. Sorry, I was going on my little rant. But it's like, why can't we do that? Right? Why can't we just, get ourselves together? We're so worried about, we got to pay rent and we got to pay that. We always got to pay something. Jesus. Not flying too afraid? All right. Because where are you? Are you in Ohio? Because I was about to say. Okay, if not a flight, something. Quick train ride out of town. I don't know. One day, no matter what it is, maybe facing that fear of flying. I know it's not very encouraging lately, but she's like, girl, have you seen the news? Things are dropping out of the damn sky. I'm like, ugh, I know. Maybe not a great example, but something. Or, instead of waiting to dress up, just one day, just wake up and be like, you know what? I'm going to do it up. I'm going to go to like a fancy restaurant, not like Burger King, not like that. Don't do that. Like, go somewhere that you're like, I always wanted to go there. You don't have to wait for someone to take you there. You freaking go. Go ahead, dress yourself up to the nines. Put on a beautiful dress, put that suit on, look, and just go. And just enjoy a meal. Get one of those, Tommy Hawks or the big chop ones. Just go freaking nuts. And get a dessert. Even if you didn't finish it. And get a dessert. Take it with you. Who cares? You know what I'm saying? Yeah. Just go ahead. I'm back to Texas, but still. Yeah. Just want to go. You want to go and see something for once. Life's too damn short. Well, I'm not going to keep ranting and raving, but I just wanted to kind of let you guys just state, like, I want everyone, it's like non-math thing. I want you to make a list. And everybody wants to call it a bucket list. I don't care what you call it. I just want you to make a list and just dream big. Don't even let money get in the way. Just dream big. You never know. You never know. Dream big. You want to travel to what? Africa? You want to see what Australia is all about? Obviously, that is not a day trip, okay? And you don't want to be in economy. Like, you want to travel. Have you ever flown first class? Wouldn't you like to fly first class? Do it. Do it. Let's see what that bougie comfort is about. And if it's not all up to snuff, why isn't it? And don't go in first class like, oh, I don't want to bother anybody. Screw that. That's what you paid it for. Go after it, right? Just do it. Do something. You always wanted to travel to Paris. You could travel to Paris. You could travel to Iceland. Believe it or not, Iceland is amazing. I used to live there. I played basketball there. I was in Sörkróka, right? About a good 6 hours away from Reykjavik, which is the capital. And it just was such a great experience. The people are so friendly. Everyone there is freaking beautiful. Ridiculous. I'm like, what about him? Oh, he's ugly. That's ugly? What the heck? Run through a brick wall? Well, don't run through a brick wall, but at the same time, go and break the barriers. We keep putting so many boundaries to us. We just fall for everyone's phrases. Oh, don't go here. Maybe one day I might want to go to Russia. Scare the hell out of everybody, right? And just to see it. You never know. It might be something completely different. Because, in Europe, they look at us like, how we get those videos of the children starving in Africa and it's like, all those things, right? They have videos like that for us overseas. When I was overseas, I would see, support a United States or an American child as they're going through hunger. They have videos about us. And we're sitting here like, wait, hold up. Oh, where was I? I think I was in Luxembourg at the time. It was Luxembourg. Yeah. And they have those like poor kids support a child in America. I'm like, wait a second. Hilarious. So it's after a while, it just gets crazy. And I have to look at it, and maybe I'm being very morbid, that life is so short. Last year, I lost a lot of kids. Either suicide or they unalived themselves. I don't know. I'm trying to figure out my wording. Some of them had contracts on their heads. Some of them were in car accidents. I mean, like, I don't even know how. I just got so sick and tired of funerals. Like, I felt like it was almost like every week it was a new person. And I thought it was bad the year before when I had a lot of my former students, gang-related, gun-related. And I don't know. I don't know what's going on with these worlds and what's going on with these kids. So when I hear about what we're doing with education and, our administration want to get rid of education, or I don't know, replace it with what? They just want, we got a lot of schools that aren't performing. Well, they weren't performing before. And if you looked at those school buildings, you will see the why, and they were in a very high gang-related areas, all of them. A lot of the kids are not going to school because they're afraid they might not make it to school. And only a couple, 3 weeks ago, another gang-related incident happened in front of a local high school. 2 kids, one was running, the other one was running behind them with the pum and shot him multiple times. Shot him a couple times, he hit the ground, up close and personal, and you could see it on the camera, and it was on the news. And it was a teenage kid. It was not like a grown adult. Nope. And I'm like, dude, these kids are coming out like vipers. Yeah, spa day. Oh yeah, get some spa days. Yes, definitely do that. We have a dollar to us, yeah. Right? And it's ridiculous. I'm sorry for your loss. And it's just like, if today was your last day, would you be happy? If today was your last day, would you be happy? Would you feel like you accomplished everything? Or at least some of the things that you always wanted to do? And I've been on this planet for 52 years. I used to play professional basketball. Like a lot of people that I went to high school with or played against in college, now they're college coaches. And it's like every time I watch, the NCAA, I'll be like, I have people to cheer for. But it's just like, especially when student athletes, when they're done and they didn't know they're done either by injury, or they're done because they graduated, or they're done because the passion of sports is no longer there. That happens quite often. We're always asking ourselves, like, all right, what's our next step? Some people hit the bottle hard. Some people are owning bars. Some people are just wasting away and their depression gets them. Some people are starting families. Some people are, being success stories. It all depends on how they see life. And I would love for you guys to see life as something that's just so glorious. So, yep. And it's true. Yeah. It's true. It does depend on who you ask. It's your perspective. It's your dream. You going after your GED, you going after ACCUPLACER, you want to go back to community college to gain some knowledge. And my thing is, it's not so much the knowledge, it's more so the fact that you did something that other people probably told you nonchalantly that you were never going to accomplish. Are you sure you want to do that? That's that doubt that they're trying to place on you. And those are the things that makes me want to beat somebody to a pulp. I have that side to me that I just want to beat somebody to a pulp. Because I'm like, oh, you don't think I can do this? Watch me. Now look at me. I'm a math teacher. Don't ask me how this happened. I really don't know. I used to, I tried out for the women's MBA and I just missed it. I got the last cut. What would my life would have been? God knows what my life would have been if I made it. Basically that movie Love and Basketball, that was my life, minus the husband and the kid at the end. I used to work at a bank. I played on different teams, and yeah, that was basically my life, minus, the women's MBA and baby and kid. Yep. Right. So it's not so much questioning yourself. It's not so much you want to question yourself. It's more so take a moment to reflect. Take a moment and say, all right, where do I want to go? Okay. I'm getting a restriction. I guess I'm getting too deep. All right. Well, anyway, I'm trying not to get too deep. I just feel that just go after what you want. Okay? I don't know when that came up. But just go after what you want. Okay? Don't let anyone stop you. I'm proud that you are going after your GED. I'm so proud that you guys are going after what you want to go after and you want to try to learn this stuff. I know, right? But it's almost like take a moment to stop and just reflect on what you want. And don't hold back. It's a thought. It's a dream. You can't get it wrong. You can't get it wrong. It's your life. You can't get it wrong. And if you feel that you're going the wrong way, guess what? You're the one that can change it. Right? No one else can change it, just you. So it's so funny because you're like, wait a minute. Oh yeah, I could change that. Yeah, you can do whatever you want. And sometimes you feel like you can't, but you can. Only you're the one that's just stepping in the way. As long as you're not doing anything horrible and you're doing something that's going to be not only supportive of you, but supportive of society, then you're doing the right thing. Okay? All right. I'm going to take my tired, psychotic butt home. I'm home, but to bed. And I will actually see you guys tomorrow. I'm going to see at 1 o'clock. I'm thinking about doing arithmetic and geometric sequence. And then tomorrow evening, I'm going to start getting on to exponential. Because we need to start working on exponential. That's coming up for a lot of students. Especially growth and decay. And what's the things. All right. You need to have this talk with these. Yes. Yes. It'll be also nice. I mean, I don't know how many people will come that will all sit and just have a powwow and maybe even actually see each other's faces. I'm getting deep with people I don't even know. But yeah, I don't mind doing that. I don't mind. And it's just like, it's not all about the likes and the, oh my God, look at all the followers I'm getting. And it's nice and I appreciate it. But for me, it's more than that. I want to help people get past the barrier. That's my main thing. That's the reason why, as I'm shaking the thing, that's the reason why I'm here. Yeah, that's the reason why I'm here. Hey, city country girl. That I really want people to understand that you're valued, you are hardworking, and we see you. Because sometimes I feel that a lot of people don't feel like they're not seen. And they need to be seen. And you need to be seen. So I think that's it. I think I'm going to stop here. But again, if you ever have any questions, just go ahead and message me. I'll be here probably at 1 at the latest 1:15. But I have to get off at 2:15 because I have a student afterwards. But then I'm going to come on later on that evening just to see if that works for everyone's schedule. And then we'll take it from there. All right? Yeah, I know. I'm telling you. Just as a teacher with some of the kids that graduated, I'm like, dude, is everyone pregnant? Like, read a book. What's going on? Like, y'all didn't waste no time. And then people are getting married, and it's good. It's always great to see my kids. I call them my kids because no matter what, I still see their baby faces. But I'm telling you, I'm so proud of them. I'm so proud of them. And I get emotional thinking about it just to see how they're becoming mothers and fathers and entrepreneurs and representing and speaking and advocating for people. And it's a beautiful thing to see. And not too many teachers get to see that. And they're allowing me into their world. That's what makes it so magical. That's what makes it magical. That's why I teach. It's sure as hell not the money. Sure as hell ain't the money. I'm not saying that I'm only getting paid $2 an hour, but trust me, after you do your driving, pay for gas, pay for food, all that stuff, you don't have much left. You know, you really don't have much left, especially if you're trying to do big things. And I was always the person that had the stockpile in my classroom, like the lotion and the hand sanitizer before the pandemic started, you know. And one year, I no lied, I spent $5,000 for school supplies, like books, notebooks, note paper, pencils, pens, color pencils, markers, highlighters, compasses, protractors, rulers. Oh God, rulers. Um, Oh gosh, what else? Just things that I needed for my classroom that I use. Batteries. My God, being a math teacher, they're thinking, why do you have to spend so much on batteries? You know, each calculator takes 4 batteries. So I used to go through batteries left and right. And then this one year, I had to get my own paper. I had to use my own copy paper. Like any of the copies that I make, any of these, I had to go out and buy my own copy paper. So when people talk about education, I'm like, you have no idea what some of these teachers have to do in order to just maintain a classroom. But the powers that be want to make whatever rules that they want to make. And that's not right. Yeah. It's all too early. I can't do that until I have everything I need on my own. Yep, I gotcha. All right, my loves. Thank you so much for the likes. Appreciate it. Really do. I'm going to see you tomorrow afternoon, a.k.a. tomorrow evening. All right? So take care, my loves. Have a good one. Stay rested. Stay hydrated. Legally hydrated.